Welcome to the class. Today is our last test of this All India Test and Discussion series on Physics Optional. I am going to start the discussion of Thermodynamics and Statistical Physics test in due course of time. I have evaluated the answer sheets of almost all of you up to test 7. Test 8, whosoever has taken on last Sunday, I have evaluated their tests. This year is coming to a close, so is my test series. How was the year for the world at large? Most of you will feel that year was bad. This is not a bureaucratic answer. For a bureaucratic answer, you cannot pass a judgment. Year, definitely, if you say year was bad, for certain sections, for certain sectors of the economy, year was not bad. Year was not bad for certain people also, but people at large, definitely year was bad because Corona has acted as a great health hazard. But for Joe Biden, for Nitish Kumar and for all other people who have been successful in their ventures, like the people who in digital economy, for them this year has been a good. So this year has been a mixed response. For most of the world, due to Corona pandemic, it has been bad, but for many of us has equipped with a alternative lifestyle. We have known how to live with ourselves. We have started discovering our internal self. We have got time to analyze the things which have been going wrong. In fact, it has made me learn lot of things about digital platform. Due to this digital platform, I have been able to interact with large number of my dear students all over the country. I am going to discuss my last unit test of this AITDS 2020. Now question number 1. Question number 1. As usual, it had 5 parts. Question number 1A was quite simple. The melting point of lead under normal pressure is 600 kelvins. What will be the change in its value when pressure is increased to 100 atmosphere? The density of lead in solid and liquid phases. So definitely phase transition is taking place. Melting is there. So melting is called solid to liquid. Solid to liquid. Solid phase might have had volume V1. This is having volume V2. And these are the specific volume. Specific volume. Specific volume means volume of unit mass of this thing. This will be rho solid. So this is 1 by rho, and this is also 1 by rho liquid. So question is, the density around both the things has been given to you. Latent heat is given to you. What will it change in its value? Melting point change you have been asked. You have been asked what is delta T. So this question, this solid to liquid conversion is there. This phase transition occurs at constant temperature and pressure. Constant temperature and pressure. And entropy changes and volume changes. That is, first order derivative of this function is changing. Therefore, this is the example of first order phase transition. This occurs at one particular temperature, melting point, and one particular pressure. When they are changed, pressure is changed. How temperature changes? That is obtained by Clausius-Clapeyron equation, which is the equation of first order phase transition. What is Clausius-Clapeyron equation? D by dt is L upon T V2 minus V1. This is called Clausius-Clapeyron equation. You need to explain all the terms. Here V1 and V2 are specific volumes in phase 1 and phase 2. dt is the change in melting point, L is the latent heat. Explain. Every data is given to you, T is given to you, V1 is this, 1 by this, V2 is this, all the data given, substitute, answer will turn out to be dt is 0.754 Kelvin. That is dt or delta T. This answer is correct. I have given you 6 marks. If your answer is correct, I have given you 6 marks. Provided, definitely when answer is correct, this will be written. You have to explain here V1 and V2, they are specific volumes. You have to say that is the first order phase transition. Because whenever solid is converting to liquid, temperature and pressure remains constant and entropy and volume undergoes a change, which are nothing but the derivative of first order Gibbs functions. Whatever order derivative of Gibbs function is discontinuous, change is said to be of that particular order. You would have written this thing in footnote, I would have given you half extra mark. Good. That was the part A. Straightforward. If your answer is wrong, formula has been written, I will give you 2 marks. And provided here V1 and V2 have been defined, 2 out of 10. Formula has been written, V1 and V2 has been defined, Clausius Clapeyron equation has been written, answer is wrong, I will give you 2 marks. So try to see what is the difference. Difference between 60% marks and 20% marks is only of the numerical answer. So, and numerical is formula substitution, very straightforward numerical. So whenever you are going to attempt a numerical, try to check the calculations twice and write everywhere units. Wherever the units, here Kelvin scale is read, Kelvin you write. Good. Now next part, B part. Calculate the variation of Cp with pressure at constant temperature for a substance whose equation of state is given to you, RT upon P minus C upon T cube. ये चश्मा नहीं है मेरे पास, T cube है, T square है. You have been asked change of Cp with pressure. So you have been asked, mathematically speaking, you have been asked what is del Cp upon del P at constant temperature. This has been asked. So whosoever has done this course thoroughly, have studied, they know that del Cp immediately should be clear to you that del Cp upon del Pt has been asked, and this is equal to minus T del 2V upon del T2P. If you have done the course, you know this is the standard result. Although it has to be proved here. For proving this result, I will give you, this is 5 marks. This is 5 marks. I will give you 3 out of 5 for this part. And next, whenever you will substitute del V upon del T at constant pressure is R upon P minus 3C upon T raised to power. Okay, the constant temperature 3C upon T4 del 2V upon del T2 P. Whenever you will do at constant pressure, it will be 15C upon T5. ये T क्यूब है, अगर T क्यूब है तो ये ठीक T5 15C upon T5. If it is T cube and if it is T square, then this will be your T cube here. I think this C upon what people have taken. Just hold on. Just let me check. I think according to my typography, it is upon T4. I have given you here T4. I have given you TQ. So I have given you, this is 12, 15C upon T5, correct. I have given you the same. I have checked from my paper, I have given you only TQ. So 15C by T4. So now what will be del substitute here? Del Cp upon del Pt, it is minus T minus 15C. Oh, sorry, 15, 12. 12C, C is a constant, upon T5. So it will turn out to be 12C upon T4. 12C upon T4, correct, that is answer. So answer of this is del Cp upon del Pt is 12C upon T4. This is the answer. This answer will give you 3 marks out of 5. This derivation will give you 3 out of 5. Within a page, I can write all these things. Is a standard given in the textbooks? Nothing. So try to appreciate. This has to be correct. If this is not correct, only derivation has been done, I will give you 3 marks. But without derivation, if you are writing, then also I am going to give you only 4 marks. Because then I will ask how this thing appears. Try to appreciate. Within 1 page, I can write. So first I am giving you the answer. So answer was this for 5 marks. For 5 marks, you have to give me this derivation. How del Cp upon del P is to be obtained. How del Cp upon del P to be obtained. So you know what is Cp? What is Cp? Cp is defined as del Q upon del Tp. What is this? T del S upon del Tp. So now it will turn out to be, try to appreciate, what is this? Del upon del P of T del S upon del T P at, everything is to be evaluated at constant T. Good. That is what del Cp upon del P. I have just substituted what is Cp. Cp I have written del by del P at constant T. Good. Try to understand. This whole bracket is being evaluated at constant T. So I can keep this temperature out. T del by del P of del S by del Tp at constant T. Good. Now crux here is that entropy is a state function. We know entropy is a state variable. If it is a state variable, I can take S as a function of T and P, then I can always write del upon del P, del S upon del Tp, constant T is del upon del T, del S upon del Pt, constant P. That is how I would have written. Entropy is this ratio. Why I have written this? Because I know no Maxwell can be used on this. Maxwell is on the PV is equal to ST. These kind of things. So on S by T, this thing Maxwell cannot be used. So I cannot convert into the given equation format. Therefore, I have written this. So del by del P I am substituting in terms of del by del T, del S by del Pt P. Correct? Now I know very well what is del S by del P T. PV is equal to ST. That will become del V upon del T P. PV is ST. Correct? And Satyaprakash Devar tells truth. So minus sign. Minus sign. I have given a very simple thing. Name is Satyaprakash. So I doubt that Satyaprakash speaks truth. So I have written minus sign. So it simply becomes minus T del upon del T, del upon del T, del V upon del T P. Good. And our constant P. So simply it becomes minus T del 2V upon del T2 P. So derivation you must be clear. Within our page I have done it. This question was asked in the exam also. In real exam also this question derivation was asked. This derivation is important. Along with this, any such kind of questions I can ask you. Similarly, if I would have specified, I can also ask you del CV upon del VT is what? This kind of questions also I can ask you. So try to do this. That was the B part. Good. Half marks for presentation. So 3 marks for derivation, 3 marks for correct answer, half marks for overall presentation within a page without any cut work. Neat and clean. If you have presented neat and clean, you have written something extra, I would have given you half mark extra, but within a page. I will not give you space more than this. So C part. Now 1C. An electric current of 10 ampere is maintained for 1 second in a resistor of 250 ohms. I have been given a resistor of 250 ohms and a current is flowing. What current is flowing? Current of 10 ampere is flowing. 10 ampere is flowing. And what I am specifying? The temperature is 27 degrees Celsius. That is 300 Kelvin and it maintained. That means temperature of the wire is not changed. Temperature of the resistor is not changed. That is state of resistor doesn't change. Doesn't change. That is what is the conclusion I got. Just I have written. Now, what is the entropy change of the resistor? 5 marks. What is the entropy change of the inverse? 5 marks. That is how 2 part question I have asked. I am asking the question on entropy change. Entropy change of resistor. First of all, here answer is 0. Entropy change of resistor is 0. And for writing this answer, I will give you 3 marks. 3 out of 5. But it has to be well presented. Otherwise, only for writing this, I will give you 1 mark. Only 1 mark. So you have to specify me what is entropy. Entropy is a variable of state whose only difference between 2 equilibrium states is corrected. And from one entropy, because it is a variable of state, I calculate the entropy change between 2 states. And both these states, in between where the entropy change is calculated, those states are equilibrium state connected by reversible path, reversible process from state A to state B, from initial state to final state. Transition must be by a reversible path. That has to be specified clearly. Without that, I will not give you even 3 marks. For answer, I will give you only 1 mark. For correct thing here is entropy change is calculated. And change of entropy is always calculated. Change of entropy is a variable of state. Entropy is a thermodynamic variable. Is a thermodynamic variable of state whose change is calculated between 2 equilibrium states connected by reversible path. So if state does not change, if state of the resistor does not change, entropy change will be 0. Delta S will be 0. Because here given state does not change, therefore entropy change is 0. That justification is required. Once this justification is given, I will give you 3 marks. Now, in second part, inverse delta S inverse will be delta S resistor plus delta S surrounding, delta surrounding. Surrounding is what? It is throwing heat. Definitely it will produce heat. So how much heat will be released? Definitely now state will change. Now out for surroundings, delta S surrounding, heat will be I square RT upon temperature. That is your, you can write in joules per degree Kelvin per second. In that sense, you write, you calculate this whole answer, it will turn out to be 83.33 joules per Kelvin per second, because time is not given. So per second, whenever I will write, this I will write per second. Good. So this is, so delta S inverse is same as surrounding, so 83.33 joules per Kelvin per second. Answer is important, it's correct. I have given you 3 out of 5. Definition of entropy and other things has been written, I have given you 6.5. Good. Entropy you can make. Okay. Now question number, that was C. Question number D. Clear? Question number D. How the answer is presented? One page. 1C. 1D. 1D. Question 1D. Calculate the van der Waals coefficients A and B. A and B calculation. Second part here is diameter of a molecule. Diameter of He molecule. Good. What is given? TC, PC given. TC, PC given. Data is given. And R is given. Good. What marks did you guess? This will be for 5 marks. This will be for 5 marks. That means for 5 marks, A and B, that is 2.5 marks for A, 2.5 marks for B, and 5 marks per diameter of the molecule. If A and B value is correct, I will give you 1.5 out of these two. Definitely if diameter is correct, I will give you the 3 marks. If only formula is correct here, I will give you here 1.5 marks. 1.5 marks. So TC, PC is given, A and B is required. A and B is required. Good. Very simple. I know, straight I know from my memory, B is VC by 3. B is VC by 3. And what is A? 3 PC VC square. I know this. From my, definitely I knew VC is equal to 3B, PC is equal to A upon 27 B square, TC is equal to 8A upon 27 RB. From my memory I know. And I also know, you can cross check and remember, PCVC is 3 by 8 RTC. These comes from memory, from standard derivation, from practice. Need not put your mind on this, that PCVC is less than 1. And in fact, ये याद कर लो, PCVC by RTC is eta, it is 3 by 8, less than 1. Good. So, deliberately I have given TC and PC. VC I can get from here. From this equation, simplest is, how I can get VC? VC is 3 by 8 RTC upon PC. Good. VC is 3 by 8 RTC upon PC. If VC is calculated, then B becomes simple, VC by 3 substitute, get the value turns out to be, B turns out to be 2.42 into 10 raised to power minus 5, simplest, meter cube per mole. Volume hai co-volume. B is called co-volume. So it is what dimensions? Meter cube per mole. Don't forget. If you have not written unit, answer is correct. I have given you only 1 mark. Both the things are correct. I have given you 1.5 marks. So 1.5 marks for this answer to be correct. Straight away I told you how it is to be written VC by 3. VC is to be 3 by 8, RTC 1 PC. Correct. Now A is state 3 PC, VC is equal PC is given, VC you have already calculated from here. Then it will turn out to be, A will turn out to be 3.59 into 10 raised to power minus 3. Answer is correct of many people. But Newton meter 4 upon mole square. This is the unit. यह निकाल के वहाँ से लिखनी है आपको. Both these things has to be correct. If they are correct, 1.5 marks. और इसमें खुश होके अगर ये आपने लिखा है सही, तो मैंने आधा और एक्स्ट्रा दे दिया है, हाफ extra. That is how I have given 3.5 marks out of 5. That is how the marking is done. That is how marking must be done. It clear? Clear? A and B, A part. Second part, diameter of molecule. So you know B is a co-volume. So what is this co-volume? Co-volume is typically 4 times Avogadro number times the volume of one molecule, which is typically treated as a sphere. So D is the diameter. If I take D by 3 whole cube. So B co-volume is 4 into Avogadro number into 4 pi by 3 D by 2 whole cube. B is known to you. If B is your correct, then only D part will be correct. So if this thing is correct, I have given you 1.5 marks for formula, because your answer may be wrong, but this formula is correct. You have to write diagram. If you will make diagram here also, then I would have given you, explain something more, I would have given half mark extra here. So I have given up to 2 marks for this thing. And substitute, answer will turn out to be, D will turn out to be, if I am not wrong, 2.68 into 10 raised to power minus 10 meters. These calculations, very little scope is there of being wrong, because these calculations have been checked by the best of the crowd in the country, and on that basis only I have awarded the marks. Cross-checked calculations, data has been cross-checked from the best of the students, that their answers and my answers are matching. Good. So it's clear. D part once again I am writing. What was the answer for D? Answer for D was 2.68 into 10 raised to power minus 10 meters. That was the diameter of the helium molecule. Correct? From the knowledge of these critical parameters, I have calculated. I have told you in this question I would have given you up to 7 marks, because this question was long. In fact, I would have asked this question for 15 or 20 marks in the real exam. But in this MITRE series, I have asked it for only 10 marks to give you a proper practice. Good. D part. E part, the coefficient of viscosity eta at 15 degrees C. Eta at 15 degrees C is given to you as 196 into 10 raised to power minus 6 poise. Poise is a CGS unit of viscosity. 10 poise is 1 SI unit. If you want to convert into this. Remember 10 pies is 1 SI unit. Good. So let us calculate only in CGS. That function will calculate the diameter of the molecule of this gas. Only this is given to you. And molecular mass of the oxygen is 32 atmosphere. Good. So diameter is required, eta is given. What is eta? From transport phenomena, eta is 1/3 m n v lambda, where every term has got their usual meaning. M is the mass of a molecule, single molecule. N is the number density, V is the velocity, lambda is the mean free path. Lambda is the mean free path. Good. So what is lambda? We know lambda is 1 upon root 2 pi sigma square n, where sigma is the diameter, n is same. So if I substitute here, it will become 1 upon 3 root 2 pi sigma square m into V. That is what I will write if I substitute for lambda mean free path. Then it will turn out to be eta. Now it is still not the function of temperature. So 3 root 2 pi sigma square m. What is V? You have to say that, assume that they are following Maxwell-Boltzmann formula, Maxwell-Boltzmann distribution. Molecules of this gas are following, molecule of oxygen are following Maxwell-Boltzmann distribution. You have to assume here. If they will assume, they will follow Maxwell-Boltzmann thing, then V will be written as root 8 kT upon m pi. Kb is the Boltzmann constant. Now everything is on to you. Eta is given, temperature is given, sigma is to be calculated. Correct? But you have to write here molecules of oxygen at given temperature, because this thing important. Assume Maxwell-Boltzmann distribution. Therefore, V is root 8 kT upon m pi. You write all those things. I will give you 3 marks out of 5. Only for writing down this thing with this, all those things. If you are not writing all those things, I will give you only 2 marks for writing down the formula. 2 and 2.5. Proper justification, you will write this. This was not required, just only for your knowledge purpose I have told you. Substitute everything here. Formula substitution problem, I will call this kind of problem as a formula substitution problem. Diameter will turn out to be 2.99 angstroms. D will turn out to be 2.99 into 10 raised to power minus 10 meters. Cross check. If your answer is correct, 3 more marks. 6 out of 10. Half mark for, I've already told you, half mark I can write for nice presentation, this thing, Maxwell-Boltzmann, so on and so forth. Viscosity defined by this formula is defined from transport phenomena. Viscosity is a transport of momentum. According to transport phenomena, viscosity of gases can be regarded as transport of momentum. Relative layer between the layers of the gas results into transport of momentum. Added something like this, I would have given you half mark extra, or molecules following Maxwell-Boltzmann distribution, something else you would have written. Any such information apart from the correct formula and correct answer, I would have given you half mark extra. Half marks for this part, half marks for the formula. Once again I am just rewriting m upon 3 root 2 pi sigma square root 8 kT upon m pi. For writing all those things, I have given you the marks. Correct? That was the party. Clear? I have been able to clearly spell out 3 marks. 3, half mark extra. That is how I have given you 6.5 out of 10. Whosoever has taken test at On last Sunday, I have evaluated answer sheets of each and every person. And whosoever has sent it later on, I will be evaluating today or tomorrow. By tomorrow, I will be clearing my all backlog up to test 8. Test 7, whosoever has taken test 7, I have evaluated answer sheets of each and every person and has been sent to you. Good. This year I have been missing my dear students because typically I always teach by interacting with the students. I see the response on your face, but this time my classroom has had 4 or 5 students only. Typically, otherwise the class is typically full in my test series class also. So this is a novel experience for me. When I am interacting with a wider cross section of students sitting across the length and breadth of the country, I do not know how much benefit my test series has been able to offer you. Only the result of Civil Services Examination 2020 will be able to tell it. Good. Now question number 2. What is adiabatic demagnetization cycle? 20 mark question. How do you achieve very low temperature by this method? Derive an expression for fall of temperature and show that more cooling is produced when temperature is low. Is a 20 mark question. Rest of both the parts are 15 marks each. So what is adiabatic? And almost whole question 2 is very simple according to me, because A and B are straight derivations and part C is a simple numerical. So question 2 was very simple, could have been very well done within 30 minutes. You could have saved 6 minutes of time in answering the question number 2. If your practice is proper, question number 2, every question in UPSC examination on an average are allotted 36 minutes, because 5 questions in 180 minutes. So one question in 36 minutes. Question number 2 must be also in 36 minutes. But question according to me is so simple, because many of you can crib me that question 1 was lengthy, sir. If question 1 was lengthy, then my question 2 and question 3 and other questions are short. You can always save time from these questions to devote more time for solving the compulsory part. You can do that. And that is what I am recommending in the real exam also. In the real exam, whenever you are going to choose 3 questions, choice questions, those questions, because many of them will be derivations and you have already practiced them many times. So you will be able to save, in every question you are able to save about 6 to 7 minutes. 3 questions you are able to save 21 minutes. You can devote those 20 minutes extra in solving question number 1 and 5. Question number 2. What is the adiabatic demagnetization cycle? What do you achieve by this? How do you achieve very low temperature? So this is for 10 marks. 10 marks is derive an expression and a tail, so that more cooling is produced when temperature is low. So there are 4 parts to this question. What is adiabatic demagnetization cycle? I am asking what is cycle. I am not demagnetizing. So what is cycle? Cycle is this. Try to appreciate. Draw this kind of indicator diagram. Here is temperature. On this scale, you draw entropy. On entropy. Yes. And here B is 0. No field is there. And here B is applied. When B is applied, entropy will be less, because when the magnetic field is applied, system will become orderliness. And now try to remember, when no field is there, then molecules are randomly aligned of the adiabatic salt. But whenever the B is applied, they will become more orderliness, entropy will be less as a consequence. Good. So cycle is at constant temperature. This is first step. B is equal to 0 to B, isothermal magnetization. I will switch off the field. This is this constant entropy process. The adiabatic process. This is adiabatic. B is equal to 0, adiabatic demagnetization. It results into so much fall in temperature. This is one cycle. Then next, once again I switch on, I come here, now switch off, this is the cycle. You have to write this. This is adiabatic demagnetisation cycle. Adiabatic demagnetisation cycle is used for achieving temperatures in the vicinity of absolute zero. Lower will be the initial temperature. If it is 2 kelvins, I will be able to reach very quickly near 0.0025 Kelvin. These kind of temperatures can be produced from this. Okay, the cycle is clear. This diagram was essential for cycle. Cycle I am asking for 5 marks. How do you achieve very low temperature? By this method. So here you have to talk to me about the theory part, not derivation. How will you achieve thing? You are achieving whenever a adiabatic specimen was, whenever a paramagnetic salt was there, no field was applied, it was here. I first bring the specimen at the initial temperature of the liquid part T1 at the initial temperature T1, it is here. By applying the field, if some heat is generated, that heat is conducted away to the vacuum tube. So T1, this first step is isothermal magnetization. Then switch off the magnetic field, and whenever magnetic field is switched off, dipoles which have aligned in the direction of field, now they will get de-aligned. In that process, because this process is at the constant entropy, that is adiabatic process, those de-aligning dipoles will do work at the cost of internal energy. As a consequence, internal energy will fall, temperature will fall. This is the phenomena that has to be written here. That is what precise. How do you achieve low temperatures? And for low temperature, cycle is done. First process you have the great reduction, and then quickly can reach very low temperatures. Write down that. Derive an expression for the fall of temperature. Now you have to derive me the expression for fall of temperature. This delta T is minus C upon 2 CH T square. This you have to derive. C upon CH, fall of temperature. This just let me see. From the standard result, you have to get V. Delta T will be, so into B square, sorry, T square is, sorry. See, that is what I was right. Into your B square. That is the magnetic field square. So you could have very well written this. So if this I here, this would have been, in fact, if you would have integrated, here it will be T average. There is T average for many cycles. Otherwise, TF minus TI square correcting, you will be getting this. TF is square minus TI is square will be something minus C upon 2CH into B square. B is the magnetic field here. I would have written TF minus TI delta T. So it can be written to this format. So here thing is not tail part. Lower the initial temperature, T average, lower will be the T average, higher will be the fall in temperature. That is how it can be argued out. C by CH are the constants. B is the magnetic field applied, fixed magnet. So fall in temperature is inversely proportional to initial temperature. Lower will be the initial temperature, greater will be the fall in temperature. That is what it is depicted from the diagram. Lower will be the initial temperature, greater will be the fall of temperature. That is how you have to argue here. B part, so that entropy is a path independent function, find out the expression for change in entropy of 1 gram mole in terms of P and V, P and T and T and V. Standard derivation is there, 5 marks each. All the parts are correct. I have given you 3 marks. Entropy is a path independent function, start from the classes. Inequality, take the delta S less than equal to 0 for reversible and irreversible paths, and so this straight. Now this was 20 mark questions. That is what I have discussed. Calculation of entropy, whichever I have asked for find out change in entropy of an ideal gas. So simply for ideal gas, 3 derivations are there for in terms of P and V, P and T and T and V. In 3 terms, standard things, 5 marks is 3 marks each I have given. That is how I have done the mark. C part 2C. Mean free path of a molecule is given to you as mean free path 2 into 10 raised to power minus 7 meters. This I have given to you. and already I proved lambda was 1 upon root 2 pi sigma square n, and if they follow ideal gas behavior, then P is nkt. P is simply, n is the number density, nkt from this. So n can be written, number density can be easily written here, P upon kt, that is lambda. Lambda is kt upon root 2 pi sigma square P. Everything is kept constant. Lambda is directly proportional to temperature. That you must know. Inversely proportional to pressure also. Calculate the probability of this gas. Molecule will travel 6 into 10 raised to power minus 7 without a collision. Number of particles changing without collision is n minus x by lambda. Definitely the derivation is given into the book. You can cross check. After number of particles surviving, this is called survival equation. This is called survival equation. Survival equation means number of molecules surviving the collision, that means travelling without collision after travelling a distance x, is given by n0 e raised to power minus x by lambda. This and probability will become number of particles surviving divided by n0, it will be probability. Good. So what is asking? Without making, if temperature is doubled, calculate the probability if the temperature is doubled. So let us say probability is first nx by n0 is something P is e raised to power minus x by lambda is there. Now what will happen when it is doubled? If the temperature is doubled, what will happen to lambda? If pressure is not changed, assume, then lambda will be your proportional to your temperature. So lambda dash will be, now if temperature is doubled, then lambda dash will be your 2 lambda. Lambda dash will be your simply 2 lambda. So now I am asking this probability, I want to get e raised to power minus how much distance they have to travel. Now it is the probability of now the fraction of molecules any point of time are given by this at the distance x, they survive collision. So probability will be nx by n naught. Now e raised to power minus x, x is given to you with 6 into 10 raised to power minus 7 meters, and lambda is doubled. So now what was the lambda earlier? And earlier lambda is given to you 2 into 2 into 10 raised to power minus 7 meters. So now everything is cancels out. E raised to power minus, just calculate, this cancels out, e raised to power minus 1.5, and this will turn out to be 0.223. It was an unsolved problem from this Garg Bansal Ghosh book. Cross check. Answer is 0.223. So you have to write me these things here. Question is for 15 marks. For you could have derived this also. Fraction of particles travelling dn by dx is proportional to n. This dn by dx is proportional to your initial particles decreasing. So dn by n, just formulate this, dn by n, some proportional lambda I call, then it will be your minus kx lambda x integrate, so on and so forth. You will get this. Check this derivation from the book. I was expecting this derivation also. Answer is correct. Derivation of this thing is written. I have given you 7.5 marks out of 15. Derivation has been done here for this thing. Derivation has been done for this thing. I have given you 9 marks. E raised to power minus x by lambda, this term. That is how I have done the marking. Few people have definitely done the derivation within, because 15 mark question can be answered in 2 pages. And this answer is only 1 page. You can elaborate and garnish the answer. Answer was important. If everything derivation, other things has been done, answer was wrong, I would have ideally given you 5 marks. See, so question number 2 I have completed. Now question number 3. Question number 3, A part. So that Joule-Kelvin coefficient shows departure from Joule's and Boyle's law, and hence analyze the result of porous plug. Joule-Kelvin effect is very important from this year's examination point of view. Instead of directly asking, derive an expression for fall of temperature and other things, I have asked indirect the same question, Joule-Kelvin coefficient. So you define what is Joule-Kelvin coefficient. Joule-Kelvin coefficient is del T upon del pH. That means for an isoenthalpic process, change of temperature per unit change of pressure is called Joule-Kelvin coefficient. So you have to calculate this. Joule-Kelvin coefficient has to be so that it has to show departure from this. So basically EH, I can write EH as a function of T and P. Then I would have very well written starting from this del T, I want del T upon del pH. So let us say how I would have written. So or I would have started from here. Del H upon del TP. Del H upon del TP. Next term will be del T upon del pH. Next will be del P upon del H T is -1. Straight away you would have done this 15 mark question. So from here, del T upon del pH, that I wanted. Try to appreciate. Del T upon del pH is -1 upon del P upon del H T into del H upon del TP. Correct? Now you know del H upon del TP is called CP. Because you know this. DH is TDS plus VDP. You know this. DH for a homogeneous thermodynamical system, DH is TDS plus VDP. So whenever I will calculate del H by or CP was your del Q upon del TP, this was your DQ. At constant pressure I would have always written del H upon del TP is CP. This is del H by del TP is CP. This you would have no justification required. So simply I would have written here. So try to appreciate mu is del T upon del pH is -1 upon CP. Now 1 upon del P upon del HT will become simply del H upon del P T. Correct? That is what I would have written. I am teaching you very simple derivation of this because this is important from examination perspective. From the very basics I have done. So mu turns out to be, definition is del T upon del pH, isoenthalpic process is 1 by Cp del H upon del Pt. H you know is what? What is enthalpy for homogeneous thermodynamical system? H is U plus Pv. So it is nothing. -1 upon Cp del upon del P of what? U plus Pv at what constant? Temperature constant. Evaluate. -1 upon Cp. It becomes del U upon del P T plus del of del P Pv. That also I would have taken at constantly. Correct? Correct? Good enough? Good enough? This is the departure from from Joule's law. I will explain. And this term denotes departure from Boyle's law. For real gases. Here, if the gas is ideal, I am just giving here explaining ideal gas. What is Joule's law? Joule's law tells you that U is a function of only temperature. Then del U by del Pt is your 0. Or del U upon del Vt is what? 0. This is Joule's law. So if this gas is ideal, then del U by del Pt is 0. If it is not 0, if mu is not 0, that means it can come from this or this. And for an ideal gas, what is Boyle's law? Boyle's law is that pressure is inversely proportional to volume at constant temperature. So, del upon del P at PV, and if the temperature is kept constant, this must be what for ideal gas? 0. For ideal gas, if I plot in this scale, I take PV versus T, this kind of constant. This is for ideal gas. For real gases, it changes. This is for real gas, that is for ideal gas. So this shows departure from this. You calculate this. And so for real gases, this shows a departure. And that is how, because mu is non-zero, therefore when delta P constant is applied, there will be change in temperature. So real gases show change in temperature because they do not have intermolecular attractions. Therefore del U upon del Pt is non-zero, and they distract from the Boyle's law. That is what you need to prove. And hence analyze the results of porous plug experiment. This was 15 marks. Many people have done it correct. I have given you 9 marks. But I have explained it was a good question. Can be very well asked in the exam. Same thing will result into, इसी में next step is, whenever you will substitute this value, it will turn out to be T del V upon del Tp minus V. For ideal gas it will be 0. For real gas, for ideal gases, mu is 0. For real gases, L gases, it will turn out to be 1 upon Cp, 2A upon RT minus B. Remember this thing, this is mu. And formula substitution problem, here I would have asked, delta T will turn out to be delta P upon Cp, 2A upon RT minus B. Every term has got there. They are for real gases. So here you can interpret any numerical problem can be asked, has been asked in the last 3 years. This question is very important from examination point of view. So prepare Joule-Thomson effect or Joule-Kelvin effect in a thorough way. How does it produce cooling? Hydrogen and helium show heating effect at the normal temperatures, ordinary temperatures. And when they are pre-cooled, then they can also be cooled. B part, 15 marks question at 10 marks. For a van der Waals gas, derive the equation of state of a adiabatic curve in terms of variables T and V. B, here I wanted, what is dq? dq is very simple. dq is written as your du plus pdv. I would have easily written du plus pdv for a reversible process. This is what. So now try to understand for a van der Waals gas. What is van der Waals gas? I assume that van der Waals gas obeys this. P plus A upon V square V minus B is equal to RT. So what is P? P is RT upon V minus B. RT upon V minus B minus A upon V square. That is P. That is your P part, correct? Good. So try to appreciate dq, du I will going to solve due course of time. Du I would have taken, u I would have taken as a function of t and v. Du would have become del u by del t v dt plus del u upon del v t dv. That is how I would have taken. Del u by del t is cv dt plus del u upon del v t. If you would have calculated this, del u upon del t v would have calculated. I will just show you because I know I would have used here. I am just using del u upon del v t for van der Waals gas. For van der Waals gas, I am cutting short. Van der Waals gas is A by V square. How I would have written this? You would have easily written del by del u. Del V u I would have written TDS. Okay, du I would have written TDS minus PdV. So I would have easily written du as del by del V of TDS or T del S by del Vt minus V. This I would have written T del S by del Vt minus V. That will turn out to be T. If I will apply Maxwell, del P upon del T V minus V, it will turn out to substitute from van der Waals equation of state. Del P upon del T V will turn out to be 1 upon V minus B. So del P upon this is A by V square. Just calculate. This question has been asked, A by V square. So I will substitute here both the things plus your A by V square dV. So now from this dq is Cv dt plus A by V square dV plus P is RT upon V minus B minus A by V square dV. Straightforward dq turns out to be Cv dt for van der Waals gas plus RT dV upon V minus B. Good. Good. For adiabatic process, this is for van der Waals gas. For adiabatic process, dq is set to 0. You can simply write dt upon t, variable separable. dt upon t is minus r upon cv, dv upon v minus v. Now is variable separable equation. Integrate. You will get ln t is minus r by cv, ln v minus b plus ln constant. So simply t v minus b raised to power r upon cv is constant. Or ln k I can write, where k is arbitrary constant. That is what I wanted. Derive this within one page could have been derived. Question was for 10 marks only. So I have given you 6 out of 10. Anything else is. So by single stroke I have done so many questions into this part. Any such question can be asked. Purpose of the test series is to make you familiar with many questions which can be asked in the exam. So that is how in one question many things is coming. Now C part, once again 15 marks. What is the diesel cycle? Derive an expression for diesel cycle. It is fast question. It question could have been asked for 20 marks. But to make you practice fast, I have given you this question for 15 marks because many other times you are familiar with all those kind of things. I am asking what is diesel cycle? What is diesel cycle? This is diesel cycle. This suction. This is your compression. Then this is your heat transfer, ignition, suction, compression, ignition, working, and then it is exhaust, and then this is that is how the cycle, and then this is release. This is cycle. Try to understand. Don't cut out suction and release. They cancel each other, suction and release, but they are also the strokes. So suction, compression, ignition, working and exhaust, and afterwards is release. 3 valve, 4 stroke engine. This is diesel cycle. Now derive an expression for efficiency. Definitely I would have called this is P1, V1, T1, P2, V2, T2, simplicity, P3, V3, T3. This is constant pressure process. Constant pressure, isobaric process. So the P3 is P2, constant. And definitely this is isophoric. So V3 is this is P4, V4, T4, V4 is V1. That is what is given to you. So definitely eta is 1 minus Q2 upon Q1, 1 minus heat release into this process, CV T4 minus T1 upon Cp in this process heat is transferred, T3 minus T2. This is this 1 minus 1 by gamma T4 minus T1 upon T3 minus T2. You have to write this in terms of, now it has to be written 1 minus 1 by gamma, 1 by rho e raised to power gamma, minus 1 by rho c raised to power gamma, 1 upon rho e minus 1 by rho c, expansion ratio and compression. That is how you have to derive. It's a question of 5 minutes it could have been done. Cycle, I have given you 3 marks, 3 out of 5, provided all strokes have been clearly written. Suction, compression, ignition, working, exhaust and release. If all these things are written. Otherwise, for drawing the diagram, I have given you only 2 marks out of 5. This derivation has resulted into your another 6 marks. I have assigned this part for your 5 marks, this part for your 8 marks. 8 marks. Out of 8, I would have given you up to 5. So for writing this, I have given you 3 parts, 3 out of 8. For this, I have given you 2 out of 8. So total I have given 5 out of 8. Or 2 out of 8. 2 out of 8, that is how I have evaluated. 2 plus 3, 5 out of 8 I have given. 5 out of 8 I have given for this part, 3 out of 5 I have given for this part, 3 out of 5. Now for remaining 2 marks in this question, so I have divided 5 plus 8 plus 2. 2 marks is tail. Tail I am asking, eta Carnot is more than this. Eta Carnot is more than eta diesel. That is what I am asking. When the Carnot will be, what is the efficiency of reversible Carnot engine? Reversible Carnot engine is 1 minus T2 by T1. T2 is the temperature at which it is thrown. T1 is the temperature at which heat is received. Good. So it will become, at what temperature heat is thrown? Heat is thrown is T1 by T3. It will become T1 highest temperature. Highest here is your this temperature. Write this T3 is greater than T2. So you could have very well written this lowest is T1. So eta Carnot would be 1 minus T1 upon T3. This is eta Carnot. You have to show this, it is more than 1 minus 1 by gamma T4 minus T1 upon T3 minus T2. ये दिखाना है आपको. That is what you need to show for 2 marks. 1 minus T1 by T3 is greater than this. So simply you could have easily written, because you know कुछ भी ऐसा argument T3 is greater than T2, T3 is greater than your T2 definitely. So T1 upon T3 T1 upon T3 will be your T1 upon T3 will be less than your T1 upon T2, correct? So you can write T1 by T3 is less than whatever here you will be getting in terms of T1 by T2. So this efficiency will be more than this. That is our argument. You have to give the argument on these lines, something on these lines. Then I will give you 1.5 out of your 2 or 1 out of 2 marks to you, and accordingly I have evaluated. That was the part. So here many of the people have missed this part. How to show that eta cutoff. So 2 marks I have evaluated only for what marks? 3 marks. Here if it is everything is written. If it is not written, I have given you only 1.5 marks. Derivation, everybody has made it correct, I have given you 5 marks. 5 and 1.5, I have given you 6.5 marks. Try to understand. People would have scored 9 marks. For scoring 9.5 marks, you would have written me something on this. For 2 marks written, that was your C part. Now D part of this, almost everyone has done it wrong. Everyone. Almost everyone. Under what conditions 3D? First of all, understand the question. Under what conditions quantum statistical distribution converges to Maxwell-Boltzmann statistics? Under what conditions? What are the conditions which quantum distributions, that means whom? Fermi-Dirac and Bose-Einstein converge to Maxwell-Boltzmann classical distribution. What are the conditions? And fix up the value of mu. What is mu? Try to understand. FEI, probability of occupation of energy level EI at equilibrium temperature T, is EI minus mu upon KBT plus 1. Sorry, minus 1. This is Bose-Einstein distribution. EI is this energy level, T is the temperature. Here whatever is this mu is the characteristic energy of the bosons. Of assembly. Mu is a constant representing characteristic energy of assembly of bosons. Good. What are the values of mu? So here answer is mu has to be less than equal to 0. Maximum value of mu is 0, which occurs for photons and many other particles when the temperature is very low. And otherwise its value is always less than 0. That is what I asked. This is for 5 marks. 5 marks you have to prove this mu is less than equal to 0. And for 5 marks I am asking under what conditions they are converging. So here there are 2 ways it can be written. Definitely presentation can fetch you 1 mark, but answer has to be correct. This has to be for this GI by NI is large. When GI by NI is large, try to appreciate GI by NI in Maxwell-Boltzmann was alpha plus beta EI. Alpha plus beta EI raised to power minus 1. That is Maxwell-Boltzmann. For Fermi-Dirac, GI by NI minus 1 is e raised to power alpha plus beta EI. Correct? Minus this, not power, this same value, GI by NI. This is Maxwell-Boltzmann. This value is for, this is Maxwell-Boltzmann. Try to appreciate. Fermi-Dirac is this. And Bose-Einstein Gi by Ni plus 1 turns out to be same value, E plus alpha plus beta. I try to see from the derivations and go through my notes. Gi by Ni is e raised to power alpha plus beta Ei. For Maxwell-Boltzmann, definitely Ni by Gi will become e raised to power minus alpha plus something. And similarly here it will be plus 1. Ni by Gi could have easily asked. Good. Try to appreciate all the, I have taken the same values. So here Gi by Ni in this case is plus 1 and in this case it is minus 1. Correct? If I write in terms of Gi by Ni. So if this Gi by Ni has to become this Gi by Ni, this plus 1 and this minus 1 and this plus 1, definitely if Gi by Ni is large, I could have neglected Gi by Ni minus 1 here and plus 1 here, which is the value. Correct? I would have neglected these things if Gi by Ni is large, and this will become simply Gi by Ni. So here the condition is Gi by Ni is large, but I am asking what is the physical condition for Gi by Ni being large when Gi by Ni is large. So diagram is required for this part. Some kind of this nice diagram has been made into different books. You make this kind of your nice diagram. This is Bose-Einstein. This is your Bose-Einstein distribution. Then rest this is your Maxwell-Boltzmann. Then lower one is your Fermi-Dirac. Lower one is your Fermi-Dirac, and they converge. And all these things try to converge. This is your first one is Bose-Einstein. Second one is your Maxwell-Boltzmann. Third one is Fermi-Dirac. And here is the energy. So large values of energy, that is when the temperature is large, pressure is low. Large temperature, lower pressure, these things converge, this thing is obtained. This is one thing. So this is the condition. You have to get me with this diagram. Try to appreciate for the first part. This is one thing. Other thing, the same condition can be put into in terms of de Broglie wavelength. De Broglie wavelength. I could have very well written this. V by N, the same condition. V by N, 3m kT upon your H square raised to power 3 by 2 is very, very greater than 1. I have taught into the class. And you can read this condition from the book of S.C. Verma, Quantum Mechanics. De Broglie wavelength I have written, nothing. For quantum to converge to classical. What is de Broglie wavelength? Lambda de Broglie of material particles must be your lambda, so that is bigger than the space occupied. What is the space occupied by 1? V is the volume, N particles. This is 1 by 3. What is lambda de Broglie? Lambda de Broglie will be turning out to be your H upon P. H upon P. So lambda is your H upon P. P is your root 2m into E, which is H upon root 2m into 3 degrees of freedom. I considered 3 degrees of freedom. E is 3 by 2 kT. So simply I would have written H upon root 3m kT. Good. That is your this lambda. De Broglie must be greater than equal to your V by N raised to power 1 by 3. So you get lambda de Broglie must be very, very less than this. Sorry. So you can add this part of lambda V by N. So it will become V by N 3m kt upon h square raised to the power 3 by 2 should be very greater than 1. De Broglie evidence is this small. That is what is the criteria which I was expecting. You write all those things, I would have given you 3.5 out of 5. That was I was expecting. Try to read what is the condition under which from here it will start GI by N. This is the first part. First part of this part. Now second part is how to fix up mu. So here it was EI minus mu upon KT minus 1. That is FEI. So from here it should be clear to you that EI minus mu upon KT minus 1 must be greater than equal to your 0. EI minus mu upon KT must be greater than equal to your, this whole should be greater than 0. So I would have written this must be greater than your 0. So minus 1 must be greater than equal to 0. So EI minus mu upon KT must be greater than equal to your 1, that is e raised to the power 0, or I would have written correct. So this holds good for every value of this. I would have written this. So simply minus 1 I would have written. This must be or greater than 1. This holds good for every value of this because this is a probability. So probability Fe I is a probability has to be less than equal to 1. Maximum value of this whole term is less than equal to 1. For this term, this denominator must be greater than 0. So this will turn out to be greater than equal to 1. So this holds good for every value of EI. For every value of EI. So for every value of EI. For every value of EI can be 0 also. So e raised to power minus mu upon KT is greater than equal to 1. How it is possible? It is only possible then either mu is maximum 0, mu max is 0, or mu is less than 0. Then only this thing is possible. Try to appreciate this thing here. So this thing I will get mu is less than equal to 0 from here. That is what is the condition on mu. Try to appreciate how I have argued out. How I have argued out, try to appreciate EI minus mu by KT is greater than equal to 1, holds good for every value of EI. So therefore, mu by KT minus mu by KT is greater than equal to 1. So for this purpose, mu has to be either 0 or less than 0. So try to understand these distributions typically were quantum distributions when the temperatures are very high. And when the temperature is high, once mu has become 0, it will remain 0 or it will be less than 0. That's it. So these are the conditions which I expected for this question 3D. It was a very important and good question. Now question 4, I will not require much time in question 4 because first part is derive an expression for Fermi-Dirac distribution function at any temperature T. Standard derivation is there, Fermi-Dirac distributions. Tell me what kind of particles, indistinguishable particles with restrictions on number of particles per cell, divide, canonical distribution, other things do that. Similarly, B part, so that pressure exerted by an assembly of fermions. So particles of assembly of fermions, here assumption is that treated as B part. First part was standard derivation, 4. Now I have gone to 4a. First part was standard derivation, FEI was NEI upon GEI. You have to prove this. It was turning out to be EI minus EF upon KT plus 1 or alpha plus beta EI, whatever you wanted to write. FEI. That was A part. B part here is pressure is proportional to En raised to power 5 by 3. That you have to write. Here there are two parts here. First thing is pressure is 3 by 5 En pressure. So here you have to master line is that particles following FD distribution are assumed to be non-interacting, are assumed to be non-interacting particles, non-interacting, due to which their behavior is similar to ideal gas. Molecules of an ideal gas, behavior is similar to ideal gas, similar to molecules of an ideal gas, and they are called ideal Fermi systems, Hence, pressure is 2 by 3 E. PV for ideal gas, PV is equal to RT, or I would have written PV is 2 by 3 E for an ideal gas. So P turns out to be 2 by 3 E by V, total energy. So 2 by 3, 1 by V. What is E? E turns out to be at 0 Kelvin. If I consider, it was 3 by 5 N EF0. Good. So it will become 2 by 5 N EF0. Good. So EF0 is basically you have to derive H cross square by 2m 3 pi square N raised to power 2 by 3. You derive this. That is what is required here. 2 by 5 N H cross square by 2m 3 pi square N raised to power 2 by 3. It is proportional to m raised to power 5 by 3. That is what you need to do. Here this assumption is important. If you have not written this assumption, without justification you have written this formula, I have deducted marks. Everything you have written, these things, then you have written, I have given you 9 out of 15. That's it. Now, C part of this I need to do. C was a problem. C part I need to do. It has been asked in the exam. Question 4C. Question 4C. What is saying? Energy distribution for Ni particle in ith state is given by Ni is Gi e raised to power minus alpha plus beta Ei. Where alpha and beta are constant, Gi is the single particle states and the ith level. Using equipartition energy principle theorem, so that the correct thermodynamic interpretation is beta is 1 by kT. You have to prove that beta is 1 by kT using equipartition energy principle. Correct? If Ei is the single particle state and if it is due to one dimension motion, if I would have considered Ei to be one thing, Ai Qi square, Qi is the degree of freedom associated with this, then equipartition of energy principle will tell you that average energy plus this is half kT at equilibrium. This is equipartition of energy principle. If Ei is this, correct? Try to understand, this is given to you. Equipartition of energy principle, energy associated with per degree of freedom is half kBT provided Ei is Ai Qi square. A is a constant or Aq square. For example, I would have taken half m Vx square or half m Vy square or any such kind of things I would have taken. Good. Then I have to get average energy. This is given to you. Average energy per degree of freedom is half kBT. And use this equation for getting this. What is average energy per degree of freedom? How will get average energy per degree of freedom? So master equation is how to get, I am assuming that these particles are obeying this distribution function. No Maxwell Boltzmann, no name is to be given, this distribution is written. So EQ, you must know how I will write summation NQ, how there into EQ divided by summation NQ. That is how I would have written number of particles with the level Qi into EQ upon NQ. That is how I would have written for this part. So try to understand, this is very important. That is how I would have written this summation. So if instead of Q I would have written I, then I would have written Ni. Here I would have written EI, here I would have written Ni. But for the ith particle, try to understand EQI, which is nothing, AQ square, NQ, GI, e raised to power minus alpha out, e raised to power minus beta E, beta AQ square. Good. All these summations upon summation NIQ will become once again GI e raised to power minus alpha minus beta EI. Now whenever I am writing this, assuming this molecule, now have the assumptions that these particles are continuously distributed instead of discrete, correct? And for a single particle state, assuming GI is 1 for single particle state, or GI you cut GI for single particle states, because single particle, whenever I will go for these parts AQ square, now it will be these parts, try to appreciate this e raised to power minus, all these things will be cancelling out. Try to see this part. I am just rewriting for. So in terms of probability, if I would have written it is AQ square, for single particle state this will become e raised to power minus beta AQ square dq minus infinity to plus infinity. Single particle e raised to power minus alpha here also comes out, minus infinity to infinity e raised to power minus beta AQ square dq. This is given to H. This must be your EQ average, and that must be equal to half kBT. So try to appreciate. We now have to evaluate these integrals, minus infinity to infinity e raised to power minus beta AQ square dq is root pi upon a beta e raised to power minus alpha x square dx. It is this root pi upon a beta. Now for this part, or yes, this total value is this, and this I would have written. Definitely it is a even function, both of them are even functions, because integration I do not know the formula over this. So it is 2 0 to infinity to a, in fact after 2 a is out, q is square e raised to power minus a beta q square dq upon this integration, which is nothing, root pi upon a beta. So, 0 to infinity e raised to power minus alpha x square x raised to power n dx is 1 upon 2 alpha raised to power n plus 1 by 2 gamma n plus 1 by 2. So here 1 by 2 alpha, whenever I will write this part. So if I get this integral 0 to infinity q square e raised to power minus a beta q square dq, then it will turn out to be 1 by alpha. Alpha is your a beta raised to power 3 by 2 gamma n is 2 gamma 3 by 2. So substitute here. Gamma 3 by 2. What is gamma 3 by 2? It is 1 by 2 a beta raised to power 3 by 2 gamma 3 by 2 is half root pi. Good. So that is this integral. Given integral is this. So try to appreciate. This is 2 is already written here. So a 1 upon a beta raised to power 3 by 2 half root pi divided by root pi upon a beta. So check what will turn out to be. Root pi will cancel out. A beta raised to power half will go here. A upon 2 a beta, this is 1 by 2. A upon 2 a beta, a cancels out, 1 upon 2 beta. Good. And that is your half kT. That is your half cavity per degree of freedom. So check from beta here will turn out to be 1 upon cavity. Try to appreciate here. That is how it has to be done for single particle states. That is interpretation was required. That is how beta has to be done. I must know how single particle states are to be calculated. Try to appreciate. This was a simple numerical process. This was a problem where little bit understanding about the how average energies are calculated. You must know. That was 4 questions. I have covered A to Z of question number 4. Now question number 5. First part is standard derivation. Question 5a, I have asked del P upon del T V upon del P upon del T S. Del P upon del T V upon del P upon del T S is 1 minus 1 by gamma. Gamma is Cp upon Cv given to you. Gamma is your Cp upon Cv. 1 minus 1 by gamma, that is 1 minus Cv upon Cp. It is nothing. Cp minus Cv upon Cp. That is your Cp minus Cv by Cp. That is what is given to you. This is what I have been asked to prove. Start from right hand side. RHS. Cp is del Q upon del T P, which is nothing. T del S upon del T P. Cv is del Q upon del T V. T del S upon del T V. So Cp minus Cv is T del S by del T P minus del S by del T V, which you can easily write here as a function of T and P. ds will turn out to be del S by del T or V, let us say del S by del TV dt plus del S upon del V T dV. If I write del S upon del T P, it will be del S by del T V plus del S by del V T into del V by del T P. Correct? So if I get del S by del T P minus del S by del T V, it is nothing, del V by del T P, and here I get the Maxwell, it is del P upon del T V. Good. So this term easily I would have written T del V upon del T P upon del P upon del T V. Substitute here Cp minus Cv upon Cv. So if I want to get this will become del V upon del T P into del P upon del TV. This I required. Now in the denominator watch dt cancels out, del S by del TP, correct? Now you have to just get del S by del TP. How I would have written? Del S by del TP into del T upon del P, yes, into del P upon del S. Del P upon del ST is minus 1. Good. So del S upon del TP could be very well written as minus 1 upon del P upon del S T into del T upon del P S. I would have easily written these parts. Del T upon del P S. So del S upon del P, now this is, I would have written anywhere Maxwell on these things. Now this would be very well become minus del S by del P T upon del T upon del P. Yes, Maxwell can be written on these aspects. Try to understand. I want del P upon del T V. Already here del P upon del. So one thing has to be cancelled out. So and this del T upon del P, del T upon del PV is ST. It is del V, PV is ST. Del V by del S your P. So try to appreciate del S by del TP. I would have easily written now, and del S by del P I have written minus plus del V upon del P is T. Del V upon del T P upon del T upon del PS. Try to appreciate. Del T upon del PS is substitute. I hope you will get this, not big deal. I wouldn't have done it. Try to appreciate. You can easily substitute these things and we'll get change this. I want to change these things. I require del P upon del TV. Here I require, and these two things has to try to appreciate this. Del V upon del T P upon del S upon del T P is what has to be written. This has to be written, these two things has to be written as del P upon del TS. Hai ki nahi? Just try to see it is correct or not. Just let me check. I am cross checking. So look, if I would have written del S by del TP into del T upon del P, yes, del S by del TP into del T upon del P, yes, into del P upon del S T is minus 1. So I know del S by del TP into del T upon del P, yes. Here I use the Maxwell. if I here use the Maxwell, PV is ST del T del P upon del ST is minus del V upon minus del T upon del V. Here, yes, here I would have written minus minus plus del T upon del V, yes is 1. This thing is here. So try to appreciate that thing I get or not. I have to write del V upon del T. Yes, I want it. Del P upon del Ts is what? I take this side. So this will become good. Try to appreciate from here. Del S by I require this part. Okay, substitute, you will get this. Nothing. You write these things, this will become your del P upon del T V divided by these things, this whole del V by del T P divided by del S by del T P is nothing, del P by del T S. So that is your LHS. That you substitute from these things and cross check. You easily get. This thing comes from here. Here I have written both these things. That was A part. Now B part of this is latent heat equation. Latent heat equation L is given to you. So L as a function of temperature is given to you. Question 5B. 5B, L is given to you as 138.5 into your 135 minus T raised to power your half minus 2.48135 minus T. L is given to you. Latent heat is a function of temperature. That is what is given to you. So calculate the specific heat capacity of ammonia vapor at constant saturation at 35 degrees Celsius. Latent vaporization of ammonia. So you know specific heat Cs minus Cp is dL by dt minus L by T. That is the equation. Cs minus Cp latent heat. Now specific heat of saturated liquid is given to you. So C vapor minus liquid. C vapor. So it is going from liquid to vapor phase. This change is taking place. So C vapor, C2 minus C1 minus C liquid is dL by dt minus L by T. So differentiate. Get L at different temperatures. And dL by dt will get the value of this. Differentiate from this, you can substitute dL by dt and L at 35 degrees. Substitute L at 35 degrees Celsius. At 35 degrees Celsius, what is L? You calculate L from here. L at 35 degrees Celsius, you calculate from here, it is 113.7 grams joules per gram. Joules per gram. That is L at 35 degrees Celsius. T is 35. T is 35. Presented per degree Celsius only it is given. T at 35 degrees Celsius. Substitute into this formula substitution. C liquid is given to you. dL by dt. You will differentiate. It will value will turn out to be minus 4.45. Need to explain. Joules per gram per degree Celsius. For dL by dt you have obtained. So substitute all these things. C vapor will turn out to be minus 3.3 joules per gram per C. That is the answer. You have to write down for me this second latent heat equation. Second latent heat equation. And derive. That this answer is correct. I have given you 9 marks. Formula 3 marks. 3 marks for formula. Other calculations, explanation why it is negative value, 8 marks, 1 marks, why negative. What do you mean by negative value? Heat has to be extracted out in order to keep the vapors saturated. Heat has to be extracted out, therefore it is a negative sign. Important. Why negative? So this negative value is coming out to be. Need to explain, otherwise I have given you 8 marks. Good. Straightforward numerical given from solved problem of Garg Bansal Ghosh book. For making this paper, I had access to this book, Garg Bansal and Ghosh. Copied a solved problem directly. Copied the solved problem directly from the book. Examiner has always access to some other book while making the paper. Similarly, C part of this is a 20 mark question. 5C is a 20 mark question. How I have distributed these 20 marks? There are 3 parts into this. First part, calculate the total number of microstates, 6 distinguishable particles. 6 distinguishable particles. That means they have to obey classical statistics. Ni is 6 particles are to be distributed in 3 states. 3 states 0, E and 2E. So your G is your Gi is 3. 3 is a classical distribution. Calculate the number of microstates of the system. Number of microstates. First let me tell you the answer, then elaborate. It is 5 marks. 5 marks. Number of microstates are Gi raised to power Ni. Gi is your 3. It is 6. Answer is 729. Answer is your 729. You need to elaborate. What is microstates here? You need to elaborate. Good. This is first part. Define what is microstate. Then second part, determine the thermodynamic probabilities for all possible distributions and obtain the total energy. This is 10 marks I have divided. Determine the thermodynamic probabilities Tp and total energy. This is for 5 marks. And total energy क्या होती है? E क्या होती है आपको? EI, How many particles are there in different states? So this EI, Ni will turn out to be your, this 2 into 0, I will just put 2 into 0, first state, there are 2 particles, 2 into E plus 2 into your 2E, that is 6E. That is the answer for this part. If this is correct, I have given you 3 out of 5. Now for 3 marks, I have got thermodynamic probabilities. Here 6 thermodynamic probabilities are different macrostates. All thermodynamic probabilities. So thermodynamic probabilities are, you have to define what is thermodynamic probabilities. Thermodynamic probabilities are number of microstates accessible to a macrostate. What is Tp? Number of microstates accessible to a macrostates. So you have to write down the macrostates. You have to write me here how many macrostates are there in this. This question is because that is why this question is how many macrostates are here. So how 6 particles I will divide into 3 states. So number of macrostates 600. Then thermodynamic probability of 600. Here that is what I will ask. 600, what is this TP? What is the TP? 600 is 1. Next could be your 510. Next could be your 420. Next could be your 411. 411. And next could be your 321. Next could be your 330. And could be your 222. Because there is no restriction on number of particles per cell. So 6 could be there, 5 could be there, 4 could be there, 3 could be there, 2 could be there, any number of particles could be there on any these levels. So you write all those things. 0 E and 6 distinguishable particles are there. How I will be going to get the thermodynamic probability of all those things? So definitely TP here I will have factorial n, because these distributions are there, factorial n upon factorial n minus r, or simply I would have written pi I factorial n upon factorial ni. That is how I would have written these things. So thermodynamic probabilities for your this 600 macro state. 600 macro state will be factorial 6 upon factorial 6 factorial 0 factorial 0. That will be your 1. This one macro state. Second macro state will be your, whenever I will fill 510, that will be your factorial factorial 6 upon factorial 5 factorial 1. These are the different combinations I can make. So this will be your 6. ऐसे third 510 420 factorial 6 factorial 4 factorial 2 and this factorial 0. This is your 15. So 5, there are 7 such things. 1, 2, 3, 4, 5, 6, 7. 7. All the 7 results has to be obtained. Next is your 4, 420, 411, 411 will be your factorial 6, factorial 4, factorial 1, that is your 30. Next is your 50 will be your factorial 6, factorial 2, factorial 2, factorial 1, that will be your 60, and 6 will be your, get all these probabilities, and this will be so this is maximum, right? I've said factorial 6, factorial 2, factorial 2, factorial 1, and 6 was your 60. Then this is factorial 6, this last one, factorial 3, factorial 3, factorial 0. This is the last one, sorry, second last one. This one was your 20, and 7th one is factorial 6 upon factorial 2, factorial 2, factorial 2 is 90, correct? Try to understand. So now question was, he has asked the total energy of the distribution for which probability is maximum. So probability will be maximum wherever the number of particles, these micro states are maximum. So where in whatever the macro state, number of micro states are maximum, because thermodynamic probability is number of micro states accessible to a macro state. So this macro state 222, largest number of micro states are accessible. So accessible is how many here? This is the most probable, maximum probability 90. So this is most probable. So most probable is your 222. That is how I have calculated the energy. 0 into 2 particles summation E total is summation EI, ENI. I have simply written 2 into 0 plus 2 into your E into 2 into 2E. See, if this part would have been wrong, then that part would have been also wrong. So writing for this is half marks each. I have written half marks for these things, 6 calculations. So 3.5 here, 3 marks there. I have given you 6.5 marks here. Using the results of the TP calculation and knowledge of the permutations, verify these things. So definitely you count all those things. How many particles can be there in this number of microstats? 1 into number of particles multiply factorial and upon factorial ni. Then count all those things. It will turn out to be 729. Total will turn out to be 729 for that part I would have given you for showing this, verifying this calculation. I will give you 3 marks for that part. So is it clear, B part? Good. So 12:20 discussion of this test is complete. I have covered A to Z of this test. Good. By this today's discussion, my all unit tests are over. Test is going on today. About 10 o'clock I have given the test. Test has been sent to most of you, full length test paper 1 today. And tomorrow I will be sending you the test paper 2. And then whenever you want to take the other test next Sunday, you can take both the papers on the same day, and this test series will come to a close. And already I made an announcement. The people who have scored 100 plus marks in my average tests, if they want to take GS paper 2 and 3 and essay test, then they can request me in person or in my WhatsApp group. I will be giving that to them and evaluating and guiding them suitably. Thank you. Wish you all the best for the Civil Services Examination Mains 2020, which will be conducted from January 3, as well as a very happy new year. Let year 2021 be very happy and fruitful to all of you. You are successful, you become successful in Civil Services Examination, and